Hai, Assalamualaikum. Kita jumpa lagi dalam video kelas asynchronous datacom. So, semua okey? Selamat berpuasa. Hopefully, everybody is doing very well. Either you are in UMP Gambang or UMP Pekan, or for those yang duduk bersama family, enjoy your Ramadan in hometown. Okay. So we will continue our lecture in chapter 3. Okay. We will continue subtopic 3.2, data communication interface and networking. Okay. On the usability of OSI layer networking model, like with any tool in your toolbox, you can view the 7-layer OSI model in a number of ways. Okay, for example, first, as a framework describing what functionality needs to be present in an end-to-end networking solution. Okay, number one. Number two, you can view the OSI layer ni sebagai as a recipe on how to build a networking stack. Okay, as a recipe how to build networking stack. Or number three, as a particular implementation of the recipe, including LLC on Ethernet, CLMP on network layer, TC4 on transport layer, and so on and so forth. So what challenges do we have to solve? What is the problem we need to solve? First, in order to connect one computer to another computer through a network, so what the challenges do we have? So all these are the challenges: connectors, voltage, encoding information, units, bytes, bits or bytes, the framing of the message, error detection, error correction and recovery, congestion management, flow control, reliable transport, node and session identifiers, finding path across the network, etc. etc. What we have mentioned, multi-vendor interoperability. Okay, so we want interoperability of the equipment from various vendors. Okay, multiple transmission media. We need to we have multiple transmission media channel. For example, copper, fiber optic, and also wireless. An astonishing range of speed from kilobit per second to terabit per second, kilobit, megabit, or megabit per second, or up to terabit per second. And most importantly, we have to provide a system that cheap or affordable in pricing, and also at the same time very reliable. Okay, itulah kita punya challenges. Senang ke? Kita nak murah tapi tahan lama, tahan lasak. Biasanya murah tak reliable kan? Kalau reliable, not cheap, which is expensive. Okay, so that is the challenge. Okay, 3.3, subtopic 3.3, data segmentation and assembly. Data link layer. Framing. The data link layer needs to pack bits into frames. Okay, so you ada bits. Kita kena pack dia kepada satu frame. Okay, so you ada ni satu frame. so that each frame is distinguishable from another. Our poster system practices a type of framing. The simple act of inserting a letter into an envelope separates one piece of information from another. The envelope serves as the delimiter. So dia punya contohnya ialah as simple as kita masukkan satu surat dalam satu envelope. So ini contohnya kita ada banyak bits sebagai surat masukkan dalam envelope. Envelope ni kita panggil frame. Okay, so frame ni akan separate one piece of information, surat tadi, from another dengan surat-surat lain. The envelope serve as delimiter. Okay. So kita ada data link layer services, 3 network layer, header, packet, trailer, 1 physical layer. Okay, framing. Data link layer is responsible. Okay, ni data link. Layer number 2 from the bottom. Data link layer is responsible for something called framing, which is the division of stream of bit from the network layer into manageable units called frame. Each frame consists of the sender address and a destination address. The destination address defines where the packet is to go, and the sender address help the recipient acknowledge the receipt. Okay, so frame could be fixed size or variable size. In fixed size framing, there is no need for defining boundaries. But in variable size framing, we need a way to define the end and the beginning of the frame, the end of the frame and the beginning of the next frame. So because there is no fixed size. Okay, fixed size. Okay, tak payah define. Kalau not fixed or variable size, we need to define the end and the beginning. To separate one frame from the next, and 8 bits or 1 byte. Okay, 1 byte equal to 8 bits. An 8-bit flag or 1 byte is added at the beginning and the end of the frame. But the problem with that is any pattern used for the flag could also be part of the information. So there are 2 ways to overcome this problem first by using byte stuffing, second by using bit stuffing. Kenapa ni? To overcome the problem of any pattern used for the flag could also be part of the information. So you want to differentiate between the information and also from the pattern. Okay, from the flag. You need to differentiate either it is flag or it is the information. So using byte stuffing and bit stuffing. So this is example of a frame with character-oriented protocol. Okay, data from upper layer, variable number in characters. So sini dia punya data. A frame typically consists of flag, header, data, trailer. So frame. Okay, what is consists in a frame? Frame typically consists of flag, indication for start and end of the frame. So this is start, this is end. Okay, this is end. Header, source or destination address as well as other control information. Header. Data, ini data information lah. Trailer, error detection or the correction code here. So this is considered one frame. So is it byte or bit oriented? Framing in byte oriented protocol. Okay, byte. Framing in bit oriented. So bit kita ada bit lah. Depan ni sama, flag trailer, ni flag header. So flag header ni byte. Byte dia ada, dalam satu byte ni ada banyak bit kan. Tadi 8 bit contoh dia. So sini ni dia semua bit, tak ada byte. Okay. Byte stuffing, the process of adding extra byte whenever there is an escape character or a flag character in the data. So this is the process of stuffing extra byte into the frame. Byte stuffing and unstuffing. Byte stuffing is the process of adding one extra byte. Kalau byte stuffing, adding one extra byte whenever there is a flag or escape character in the text. Point-to-point protocol, PPP, is a byte-oriented protocol. Okay. So this is flag header. This is a frame with a bit-oriented protocol. Okay, ini ialah contoh bit stuffing. Bit stuffing is the process of adding one extra zero whenever 5 consecutive ones follow a zero in the data so that the receiver does not mistake the pattern 0011110 for a flag. So bit stuffing ni dia just masukkan kosong kalau ada consecutive 5 consecutive ones. High level data link control, HDLC, high level data link control, is a bit oriented protocol. Okay, ni contoh bit stuffing and unstuffing. Okay, so now let's see some example. Example 1, the following character encoding is used in a data link protocol. To A ialah ni, B ialah ni, flag ialah ni. Okay, flag kena ingat 1, 2, 3, 4, 5, 6. Kosong depan, kosong belakang. Escape 1110000. Show the bit sequence transmitted in binary for the 4 character frame. A, B, ESC flag when each of the following framing methods are used. Okay, ni tukar sekian. Ni sepatutnya 1, 2. Sebab ni A. So A 1 kecil, 2 kecil, 3 kecil. Yang ni B. Ni B, ni A. Okay. One of your classmate, nama apa ni? Nama you kawan lah. One of your classmate, tukar sikit tu apa? Nama apa? One of your classmate, for example, Zuhdi. Here, Zuhdi has pointed out that it is wasteful to end each frame with a flag byte and then begin the next one with a second flag. One flag byte could do the job as well, and a byte saved is a byte earned. Do you agree? Soalan dia, bolehkah kita nak tukarkan satu frame ni, dia ada 2 flag kan? Satu flag depan, satu flag belakang. Okay, tapi you punya kawan ni kata membazir lah, 2 flag ni ada 2. Satu hujung, satu start kan. So nak guna satu je. One flag byte could do the job as well. So satu je. So kita boleh savekan satu flag, satu byte. Okay ke? Do you agree? Dia tanya soalan. Okay, so you can see the answer here. Solution A. Solution. Ini A 1, 2. Ini A. Sorry. Ini 1. Ini 2. Ini 3. Okay. Yang ni ialah B ke? So this B is correct. Solution dia no, dia kata no. No. Okay. Example 2. The following character encoding is used in data link protocol. A, B, flag dia sama, kosong, 111, kosong. Escape. Show the bit sequence transmitting in binary for the 4 character frame. Each of the following method used for character count, flat bytes using ni dan starting the ending flat byte with bit stuffing. Okay, so you ada solution example 2, example 3, solution example 3, and blah blah blah. Okay. Okay, so that's all for chapter 3.2 and 3.3. So we will continue discussion for chapter 3.4, which look quite long, in the next video. So that's all for today. I hope that you can gain some knowledge, new knowledge, some information from this class. So thank you for your cooperation. Until we meet again, that's all. Okay, bye bye. Assalamualaikum.